Okay, today we're going to talk about some isosceles triangles and something called midsegments. We're going to start off with some vocabulary today, so pencils ready. In your notes, I would like you to identify the 6 types of triangles. You should already know these. These should be reviewed, but just in case, let's make extra sure they get written down. First of all, we have what's called an acute triangle where all angles are less than 90 degrees. No exception to that rule, right? Then we have triangles that are called obtuse where one angle is greater than 90 degrees. Only one of your angles even can be greater than 90 degrees, otherwise triangles don't really work. Then we have a right triangle where one angle, of course, is equal to 90 degrees. These names are all based solely on their angle measures. But then we have some more triangles where the names are based on something different. We have triangles called scalene. Scalene triangles have no congruent sides. All 3 sides are different lengths. Then we have an isosceles where at least 2 sides are congruent. Normally, when you see only 2 sides are congruent, that's called isosceles. If you have more than 2 sides that are congruent, we call that equilateral. Technically, equilateral is an isosceles triangle since it says at least 2 sides are congruent, but in general you would call 3 sides being equal equilateral and 2 sides being equal isosceles. Now we're going to throw one more triangle in here. An equilateral triangle actually has another name. We can also call it equiangular, because all 3 angles are congruent as well. If all 3 sides are congruent, then all 3 angles are congruent. So equilateral triangles are equiangular. Scalene, isosceles, and equilateral, those names are all based just on the side lengths of the triangles. Well, today we're going to focus mostly on the isosceles triangle. So let's get a picture of just an isosceles triangle and let's go through a few more vocabulary terms. First of all, the third side that's not congruent to the other 2 is always called the base. Now this triangle can be turned, so the base will not always necessarily be at the bottom of the triangle, but it will be that third side that's not congruent to the other 2. The 2 sides that are congruent to one another are called the legs. Now down here by the base, notice there's 2 angles that will always be next to the base, and those are going to be called the base angles. The base angles will always be congruent to one another. In an isosceles triangle, that is. And that top angle, which, by the way, if this is turned, won't always be on top, right? It's called the vertex angle. Notice that it's formed by the 2 congruent legs. So I have a base, 2 legs, a vertex angle, and 2 base angles, all inside of an isosceles triangle, or they're all part of an isosceles triangle. So there's 2 theorems about isosceles triangles that can help us out with certain problems that you'll see later. The isosceles triangle theorem actually says if 2 sides of a triangle are congruent, then the angles opposite the congruent sides are congruent. Now that's a lot of words, right? So let's take a look at what that actually means. That means that if AB and AC are congruent sides, if 2 sides of a triangle are congruent, then the angles that are opposite those 2 sides, otherwise known as the base angles are congruent. So angle B will be congruent to angle C. Now opposite means across from. So AC is across from angle B. AB is across or opposite from angle C. So if two sides are congruent, then the angles opposite the congruent sides are also congruent. To go with that, we have what's called the converse of the isosceles triangle theorem. And basically it takes those two portions, those two half sentences, and switches them around. This time we're able to say if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if angles B and C are congruent, then I can say AB and AC are congruent as well. That's going to help us out when we get to problems like this one, where I need to find the measures of all three angles of ABC, of triangle ABC. The only information it gives us is that I have two congruent sides, and that makes an isosceles triangle. In an isosceles triangle, my base angles are also congruent. 4x and 6x minus 36 are congruent angles. Well, measures that are congruent are equal to each other. So I'm going to set them equal to each other and solve for x. I'm going to start by subtracting 6x from both sides so I can get all my x's together. That gives me negative 2x equals negative 36. And when I divide both sides by negative 2, I get x is equal to 18. Now, like we've been talking about in class, we got to pay attention to what the question actually asked. Did it ask us to find x? No. But we had to have x to answer the question. So be careful that you're paying attention to what the question is asking for. So now, of course, I can substitute in, let's start with 4x, 4 times 18 makes the measure of angle B 72 degrees. If I substitute 18 into my 6x minus 36, 6 times 18 minus 36 gives me a measure of 72 degrees. And the two measures, of course, should be equal. Make sure you plug it into both, though, to verify that you've done your math correctly. And of course, the three angles in my triangle add to 180 degrees. Notice how it said find the measures of each angle, not just the two base angles. I have to find the measure of angle A as well. So 72 plus the measure of angle A, those three angles have to add to 180. When I add my like terms together, I get 144 plus the measure of angle A equals 180. Subtract 144 from both sides, and I get that the measure of angle A is 36 degrees. So when I write my final answer, I'm going to write all three angle measures, circle my answer, and then I'm done with the problem. Okay, let's talk really quickly about something called midsegments. Now, to start off with, we're going to talk about midpoints. Let's say that x is the midpoint of AB, so x is halfway in between A and B. On the other side of my triangle, I'm going to say that y is the midpoint of AC, so y is halfway between AC. Now these little marks that I'm putting on my triangle show me congruent segments. AX is the same length or congruent to XB. AY is the same length, meaning that it's congruent to YC. That verifies that X and Y are midpoints even if our triangle's not drawn to scale. When I connect those two midpoints, that creates the segment XY, right? XY is what we call a mid-segment. That's what a mid-segment is in a triangle, is connecting two midpoints. Mid-segments themselves have two extremely exceptional properties, and these absolutely need to go in your notes. First of all, that mid-segment is parallel to the third side. In other words, it's parallel to the side it doesn't touch, right? XY is parallel to BC. Not only that, the mid-segment will always be half as long as that third side, or the side it's parallel to. So I can say that XY is half the length of BC. I could switch that around and say if I double XY, that is equal to BC. So I could say 2XY equals BC if that's a little easier. Every single triangle out there has three mid-segments. The one that we just drew. I can also connect the midpoints of AB and BC. This creates a mid-segment. Or I can connect the midpoints of AC and BC, and that creates a third mid-segment. Like I said, every triangle has three different mid-segments. Well, if I drew all three mid-segments at once, that creates a mid-segment triangle. A mid-segment triangle, because of its proportions, right? Because the larger triangle to the smaller triangle will always have a scale factor of 1/2, then the two triangles are similar. So ABC is similar to ZYX. So let's take a look at what that can do for us in some math problems. Let's say that we wanted to find the lengths of BC and YZ. Take a look at the picture for just a minute, and then we'll move on with the problem. Did you discover that XZ and ZY are both mid-segments? Meaning that they're parallel to their outer side, right, to their third side, or the side of the outer triangle that they don't touch, but they're also half the length of that third side. So let's start with taking a look at YZ. YZ is half the length of AB. It's also parallel to AB, but that's not important right now. If YZ is half the length of AB, and I know that AB is 11.5, all I have to do is find out what half of 11.5 is, and I've got length YZ. Once I do that in my calculator, I get 5.75, and I already have the length of YZ. Now if I want to find the length of BC, which is the second segment it asked me to find, notice that XZ is its mid-segment, right? XZ is parallel to BC. It's also half the length of BC. So if I plug that in, I can multiply both sides by 2 to get rid of this 1/2, and I get that BC is equal to 9.6. To write my final answer, of course, I'm going to put them together. I'm going to say YZ is 5.75 units and BC is 9.6 units, and I'm done with my problem. Alright, I think that's enough for today. Make sure to write down any questions that you have to bring them to class. I hope your day is fantastic, and I'll see you next time.